This is Algebra 2 with Trig 5.6. We're going to find rational zeros. In the past, we've been finding the zeros of these polynomial functions, and we've been given a zero, or we've been given a factor so we could get the zero. What if we only have the function? If we don't know what the zero is, every possible rational zero has the form of p over q, and your p value is the constant term. It's the factors and the q term are the factors of the leading coefficient. So, for example, when we look down here and we're trying to figure out what are the possible zeros, we're just looking for the possible zeros. Okay? Well, it says to take the factors of the constant term, factors of 6 are 1, 2, 3, and 6. Factors of 1 of the leading coefficient are 1. So really we should say plus or minus those. So now our final answer, what are the possible rational zeros? It's that fraction. So it's plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, or plus or minus 6 over 1. No need to write the 1, but that would be your list of possible zeros. We would start to take those and plug them into synthetic division. See which one of those gives us a 0. So over here, we look for factors of 8. And that's going to give us plus or minus 1, plus or minus 2, 4 goes into it, and of course 8 goes into 8. And then factors of your leading coefficient, plus or minus 1, plus or minus 2. Now this one has 2 values for the denominator. So we're going to have to look at several different types here. We're going to look at plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, plus or minus 8 over 1. Then we look at plus or minus 1 over 2, plus or minus 2 over 2, plus or minus 4 over 2, and plus or minus 8 over 2. So you're going to take all your factors and place them over your first factor of your leading coefficient, and then take all your factors again over the next one. Now this can often be simplified. It looks like a half is the smallest one, and then we have a couple of them representing 1. No other fractions quite like that. So we have plus or minus 2, and then plus or minus 4, and it looks like our last option would be plus or minus 8. That would be your simplified list of possible zeros to try. You would take those, you would plug them into synthetic division, and you would see which one of those gives you a remainder of 0. These are possible zeros. They're not guaranteed to all be zeros. Okay? The way you can figure out which ones are actually zeros is you have to test values. from the list as x in synthetic division. Okay. Now, as these lists get pretty big, we'd say that in the old days, we had to test every one of these until we found one that worked. But now we're going to use a graphing calculator to help us get started and see what is a reasonable value to test. So for this next example, we're going to take x cubed minus 4x squared minus 15x plus 18. We're going to type this function into our y equals of our graphing calculator. We're going to graph it out, and we're trying to recognize where these are crossing. So you can sit here and count 1, 2, 3, so it looks like -3, looks like a possible 0. You could also go to table, and it looks like at 1 we get a value of 0, at -3 we got a value of 0, and at 6 we got a value of 0. Those would seem to be your reasonable ones to try. It's not really trying, we know those are the exact answers, but we're using the process that P over Q produce the possible zeros. Now we've used our technology to narrow it down so we're not just randomly going back and forth. So our factors. We're looking for factors of 18. We get plus or minus 1, plus or minus 2, plus or minus 3 goes into 18. 4 doesn't, 5 doesn't, 6 does, 9 does, and of course 18 does. The factors of the leading coefficient is 1, so that would put 1 underneath each one of those. Not necessarily useful in this case. Our graphing calculator narrowed it down to looking at -3, 1, and 6. Okay, essentially that's cheating, but we'll take it. So we're going to try -1. 1, -4, -15, and 18. Bring down your 1 and multiply. Multiply. Okay, let's see. That did not give me a 0. Now when I look back at my deal, look, -1 doesn't give you a 0. -1 looks like it might be up there at 28. Looking at our table, -1 exactly should have given me 28. So that's what it would look like if you were testing it randomly and didn't find it. So I misspoke on that one, and it doesn't look like -1, it looks like +1 and a -3 when we come back to look at our graph. -3 and a +1. But that's the way you would have to randomly plug in numbers to see which is going to work. These would be your best choices of randomly plugging in. So now let's try to plug in something we're a little bit more confident is going to work. Plug in the 1, or drop the 1 down, multiply by -3. There it is. We got a 0. So x plus 3 is a factor. Okay, so that means that we have our f of x, and x plus 3 is our factor. And what we're left with is an x squared minus 7x plus 6. We can factor that apart by saying x and x. We're going to have 6 and 1. We have to have a negative and a negative to add together to be negative 7 and multiply to be positive 6. So x has to be negative 3, x could be 6, or x could be 1. We knew that from looking at a graphing calculator, but now we have shown it mathematically that it works. So we'll start with this one. We're looking for the factors of 14. We know that that's plus or minus 1. 2 goes into 14. 7 goes into 14. And of course 14 goes into 14. If we didn't have our graphing calculator, we would have to just start with positive 1 and then try negative 1. Positive 2, then negative 2. Eventually one of those would work. Looking down at this problem for a moment, any of these would have worked. Negative 3, positive 6, or positive 1. So as I work through, I would have tested one of these relatively shortly into my guessing. Okay, so we could sit here and we could try 1, we could try 2, and so forth. But we're allowing you the option to use your graphing calculator, narrow it down, as long as you type it in correctly. Looks like it crosses at negative 1, at 2, and at 7. Going to table, we can see that at negative 1 we got 0, at 2 we got 0, and at 7 we got 0. So those seem to be the best options for us to look for. Looks like negative 1 would be a good place to start. So negative 1, we take 1, negative 8, 5, and 14. And we get that 0. So x plus 1 is a factor. Okay? Now, I would have suggested to start with 1 or negative 1 anyway. So a lot of times you'll get one that's small and you'll probably get one that's a little bit bigger. There are 3 possible zeros for this. So for f of x, we have that x plus 1 is a factor. And after we factor that out, we get x squared minus 9x plus 14. And that can be factored apart into 7 and 2, a negative 7 and a negative 2 multiply together to be multiply together to be positive 14 and add to be a negative 9. Now we want to set those equal to 0. And our actual zeros are negative 1, 7, and 2. We only use our graphing calculator to help us not have to completely randomly check these. But even if we didn't have our graphing calculator, we would start with one of the ones and then move on to the twos and then the sevens. Eventually we're going to hit it. We're going to find one that would work. So we're going to come to this next one. We're looking for factors of 35. So we have plus or minus 1, plus or minus 5, plus or minus 7, plus or minus 35. Those are the only numbers that are going to go into 35. The denominator, again, would be ones, so we don't have to worry about those so much. So going to our calculator, we would plug in the function x cubed minus 5x squared plus 7x minus 35. And we're going to notice that a reasonable one to check is at 1, 2, 3, 4, 5. Looks like 5 works. So we're going to take our 5, 1, negative 5, 7, and negative 35, multiply, and we get 0. This gives us 0, of course. So x minus 5 is a factor. So our f of x is going to be x minus 5, x squared plus 7. And when we set these equal to 0, this one is not factorable. So x minus 5 equals 0, and x squared plus 7 equals 0. You might say that it equals plus or minus I root 7, which is an imaginary solution. That means the graph does not really cross there. So it has only one real solution. One real solution, because this is too imaginary. Our last big one we've got going on here is to look at our factors of 3, which is plus or minus 1 and plus or minus 3. Trouble with this next one is that we have factors of 48. That's crazy. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 16, plus or minus 24, and plus or minus 48. So we have to do 1 divided by all these numbers, then we have to do 3 divided by all those numbers. So the possible zeros are going to be plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 1 over 3, plus or minus 1 over 4, plus or minus 1 over 6, plus or minus 1 over 8, plus or minus 1 over 12, plus or minus 1 over 16, plus or minus 1 over 24, and oh my goodness, plus or minus 1 over 48. Those are your possible solutions that mathematically this could match up with. Okay, we also have plus or minus 3 over 1, plus or minus 3 over 2, plus or minus 3 over 3, plus or minus 3 over 4, 3 over 6, 3 over 12, 3 over 16, 3 over 24, and plus or minus 3 over 48. So those are your possible zeros. That's pretty crazy. So we're now going to look at 48x raised to the third power plus 4x squared minus 20x plus 3. We're going to try to see whereabouts that this is crossing at. Try to see if we have any zeros that pop up. And when you look at it like that, we do not have any zeros that pop up. We could go to second table set and we can try to ask what our zeros are going to be. Let me try that again. We want this top one, the independent. So I could try to plug in a number and see if it works. Does 0.5 work? Oh yes, 0.5 gave me 0. 0.5 was one of my options I could try. So that's telling me that if I try a half, 48, 4, negative 20, and 3, bring down your 48, multiply it to get 24, multiply it to get 14, multiply it to get 3, would be negative 3. That's a 0. So x minus a half is a factor. So I know that x minus a half works, and that's going to leave me with (48x squared) plus 28x minus 6. From that mess, I know that I can pull out at least a 2. To get down to 24x squared plus 14x minus 3. Move the 2 out to the very front, looking for how to factor that. We could do that with the box, we could do that with the table. Looking at a guess and check format, what times what's going to give us 24? Let's try 4x and 6x, because 3 is an easy one to get. It has to be 3 and 1. So let's see if this works. 4 times 3 gives me 12, and 1 and 1 would give me, 1 and 6 would give me either 18 or negative 6. So let's try 1 and 3. That would give me 4. This is 18. So if this was a positive 18 and a negative 4, that would give me positive 14. So my possible zeros for this one come out to be, not possible zeros, these are the zeros, a half, negative 3/4, and positive 1/6. That was a tough one.